Hello students, let us start with the next module. In this module, we discuss continuity and differentiability. Let us solve the first problem. The first problem says, find the right hand derivative and the left hand derivative of f of x is equal to x minus 1, x less than 2, 2x minus 3, x greater than or equal to 2 at the point x is equal to 2, and hence show that f of x is not differentiable at x is equal to 2. Let us start with the right hand side derivative at x is equal to 2. F dash 2 plus is equal to limit h tends to 0 plus f of 2 plus h minus f of 2 upon h. F of 2 plus means x is greater than or equal to 2. So f of 2 plus h will be 2 into 2 plus h minus 3 minus f of 2 means 2 into 2 minus 3. So I'll get f limit h tends to 0, 4 plus 2h minus 3 minus 4 plus 3. So it will be limit h tends to 0, 2h by h, that is nothing but 2. Let us start with the left hand side derivative. Left hand side derivative at x is equal to 2 is given by f dash 2 minus as limit h tends to 0 minus f of 2 plus h minus f of 2 upon h. If f of x is x minus 1, what will be f of 2 plus h? 2 plus h minus 1, f of 2 will be 2 into 2 minus 3 upon h. So it will be h plus 1 minus 4 plus 3, that is h upon h, that is 1. So we have found out that limit h tends to 0 plus f of 2 plus h minus f of 2 upon h is not equal to limit h tends to 0 minus f of 2 plus h minus f of 2 upon h. That means f dash of 2 plus is not equal to f dash of 2 minus f dash 2 does not exist, means f of x is not differentiable at x is equal to 2. Let us start with one more problem. A function is defined by f of x is equal to 1 for minus pi by 2 less than x less than 0, 1 plus sine x for 0 less than or equal to x less than pi by 2. What can you say about the right hand derivative and the left hand derivative at x is equal to 0? And we need to discuss the continuity also. Let us start. A right hand side derivative at x is equal to 0 is f dash 0 plus as limit h tends to 0 plus f of 0 plus h minus f of 0 upon h. That is limit h tends to 0, f of h minus f of 0 upon h. 0 plus means will be f of h will be 1 plus sine h minus f of 0 will be 1 plus sine 0 upon h, which is nothing but sine h upon h. A limit h tends to 0, sine h by h is nothing but 1. Let us start with the left hand derivative. Left hand side derivative at x is equal to 0 is f dash 0 minus as limit h tends to 0 minus f of 0 plus h minus f of 0 upon h. 0 minus, that is limit h tends to 0, f of h minus f of 0 upon h. Limit h tends to 0, 1 minus 1 plus sine 0, that is 0. So what we have proved? Limit left hand side derivative is not equal to right hand side derivative. Therefore, the function is not differentiable at x is equal to 0. Let us discuss the continuity of f of x at x is equal to 0. F of 0 will be 1 plus sine 0, that is 1 plus 0, that is 1. Limit x tends to 0 minus f of x will be limit x tends to 0, 0 minus f of x is 1, and the limit's answer will be 1. Limit x tends to 0 plus f of x as limit x tends to 0, 1 plus sine x, that is nothing but 1 plus sine 0, that is nothing but 1 plus 0, that is 1. So what we have proved? Limit x tends to 0 minus f of x is equal to limit x tends to 0 plus f of x. Therefore, limit x tends to 0, f of x exists. Therefore, limit x tends to 0, f of x is equal to f of 0. Therefore, the function is continuous at x is equal to 0.